Okay, good afternoon. Welcome to
FamilyMath1045.
Math 1045. So you're doing a little calculus review now, and yesterday in our problem solving calculus book you learned in the section on derivatives about throwing a ball up in the air and then it goes back down. So tell me a little bit about what you learned there.
Oh, so this was with respect, we did the graphs with respect to time. So the graph looked more like a parabola like that.
Okay, so what was that? What were the axes here?
So this is height and time.
Okay.
And they gave us that they were all x squared. So quadratic equations, they gave us the x squared was always minus 16x squared.
Ah, okay.
And that was their approximation for gravity.
Yeah, that's using feet per second squared.
And then plus, this was the velocity at time 0.
And
then plus the position at time 0.
That's right. Okay, so I'll use there. We'll stay in feet. So our height was minus. It's hard for me to think in feet, but if that's what they did, that's what I'm going to do.
That's what we did.
Yeah, a height is minus 16 t squared, really, because it's time, plus the initial velocity times t plus initial position. Okay, and
This was for vertically thrown up.
that's right. So this is for when you throw something straight up in the air, how high does it go? And so the problem I'm going to talk through with you today is a slightly different problem. It's where now this isn't height versus time. This is height versus, say, position over here, and you throw a ball. Give me an angle you throw it at.
About 45 degrees.
All right. You throw a ball at 45 degrees, and it gets this. And so the question we're going to ask, did I go off camera or man?
Yeah.
Okay. We're going to ask, how far does this ball go based on how hard you threw it?
All right.
So it's an interesting question, but it's different. It's a different question than what you studied here, because here the ball is going up in the air and falling straight back down. Here it's going some distance. Okay, so that's what we're going to study.
All right.